Okay, let's get right into it. If you're building for Android with Delphi, you already know the promise of FireMonkey. It's incredible, right? A single codebase for truly native multi-platform apps. But you've probably also felt that little bit of hesitation when you run your app on a real device. That choppy scroll, that split second where the UI just hangs. Well, we're going to fix that. This explainer is all about taking those sluggish Delphi apps and turning them into the kind of liquid-smooth, high-performance experiences that users absolutely love.
Does any of this sound familiar? You've poured your heart into a feature-packed app, but the user experience just feels off. Maybe scrolling through a list is a bit jerky, what the Android world calls jank. Or you've got buttons that don't seem to react the instant you tap them. Look, these aren't just little annoyances. They're cracks in the foundation of your app. They tell the user that something's not quite right, and honestly, in a crowded app store, that's often all it takes for them to go looking for something else. We've all been there, and we're here to fix it.
And then, of course, there's the ultimate penalty, the ANR, application not responding. This quote on the slide, it says it all. An ANR isn't a friendly warning, it's the Android operating system delivering a verdict. It happens when your main UI thread gets blocked for 5 seconds or more. The OS tries to send an input like a screen tap, and your app just doesn't answer. So Android steps in, throws up that dreaded dialogue, and basically tells the user, this app is broken, it's dead. This is the #1 sin in Android development, and avoiding it is our absolute highest priority.
To really get why apps feel slow, you have to understand the budget. And it is a brutal budget. For that perfectly smooth 60 frames per second experience, everything your app does to draw one single frame has to happen in just 16.67 milliseconds. Everything. If you go over that budget, even by a little, the system drops a frame, and the user sees a stutter. They feel that jank. And it gets worse. Modern phones have 90, even 120 Hz displays. On those, your budget shrinks to a crazy 11 milliseconds, or even 8. This isn't a suggestion. It's just the cold, hard physics of how we perceive motion. Every single millisecond matters.
So how are we going to tackle this? Well, we've got a clear plan. First, we'll dig into the Android performance crisis and why the main thread is so important. Then we'll look at a huge win, modernizing your graphics engine. After that, we'll cover the golden rule of threading, get a massive boost from the Alcinoo framework, and finally, wrap up with the most important philosophy of all, measure, don't guess. Let's do this.
All right, let's start with the absolute core of the problem. I like to call it the tyranny of the main thread. See, every single Android app has this one special UI thread. It's responsible for absolutely everything the user sees and interacts with. It draws the buttons, it handles the taps, it runs the animations. But here's the catch. It's only one thread. If it's busy doing something else, your entire UI freezes solid. It's the ultimate bottleneck.
Okay, now that we understand the problem, let's get to our first big solution. And trust me, this one is a game changer. We need to completely modernize the way our app draws pixels on the screen. The default FMX rendering engine has done its job, but to really compete today, we need something better. We need Skia. Think of this as rebuilding the foundation of your app for performance. It's one of the biggest and easiest wins you're going to get.
So what are we really talking about here? On the one hand, you have the legacy FMX canvas. It's an older, GPU-based engine that, while it is cross-platform, can sometimes lead to weird visual glitches and just isn't as fast as it could be. Now, compare that to Skia. This isn't just some random library. This is the 2D graphics engine developed by Google. It powers Chrome, it powers Android itself, it powers Flutter. By switching to Skia, we are literally aligning our Delphi apps with the same tech that runs some of the fastest apps on the planet. You get better-looking graphics and a massive performance boost.
Now, you're probably thinking a change this big must require a ton of work, a complex migration, right? Nope. Look at this. This is the beauty of the Skia for Delphi library. To rip out the old engine and plug in Skia, that's it. That one line of code. You just drop that in your project startup and you're done. It is, without a doubt, one of the highest impact changes you can make for the amount of effort involved. It's amazing.
And what's the payoff for that one line of code? How about a graphics performance gain up to 50%? Just let that sink in for a second. Simply by swapping out the engine, all your drawing operations, rendering text, shapes, complex controls, they all get a massive speed up. This isn't some small optimization. It's a fundamental upgrade that gives you a ton of those precious milliseconds back from your frame budget.
Switching to Skia is a huge win for rendering, but it won't solve everything. You can have the fastest graphics in the world, but if your main thread is blocked waiting for the network, your app will still freeze. This brings us to the second, and I'd argue the most important pillar of performance. This isn't about adding a library, it's about changing how you think and how you write your code. It's about the golden rule of threading.
And here it is. This is the commandment. If you remember nothing else from this explainer, remember this. Never, ever, under any circumstances, block the main UI thread. That thread has one job: draw the screen and respond to the user. Every single moment it spends doing anything else is a moment your app is frozen. Every ANR that has ever happened is because this rule was broken. It's that simple.
So, what are these terrible things that block the main thread? Here is a most wanted list. Network operations are, by far, the #1 cause of ANRs. Waiting for a server to respond takes an unpredictable amount of time, and it's absolute poison for the UI thread. Same goes for hitting a local database, reading or writing files, parsing a big chunk of JSON, or doing any heavy number crunching. All of these things can take way more than 16 milliseconds. They have to be moved off the main thread. No exceptions.
Okay, so you move the hard work to a background thread. Great, but eventually you need to get the result back to the UI. How do you do that safely? Well, Delphi gives us two main options: synchronize and queue. Synchronize is the old way, and it's dangerous. It basically freezes your background thread and forces its way onto the main thread. The analogy here is perfect. It's like barging into someone's office and demanding they stop everything and listen to you right now. It can cause major problems. TThread.QUEue, on the other hand, is the modern, safe way. It's asynchronous. It's like leaving a polite note in a mailbox. The main thread will get to it when it has a free moment, and your background thread can just keep on working. For responsive apps, you should always be reaching for queue.
So, we've upgraded our graphics with Skia, and we've cleaned up our architecture with proper threading. Now, let's talk about a force multiplier. What if you had a toolkit specifically built to fix the biggest performance headaches in FireMonkey? Well, that's exactly what the Alcinoo framework is. It's an amazing open-source library that gives you highly optimized components that can take your app's performance to a whole other level.
Just look at this one example. It's mind-blowing. A standard FMX control might take about 3 milliseconds to paint itself. That doesn't sound like much, but if you have a list with a bunch of them, you've just destroyed your frame budget. Alcinoo's controls use a clever trick called double buffering. They paint themselves once to a texture in memory, and then just blast that pre-made image to the screen, which is super fast. And the result? The paint time drops from 3 milliseconds to 0.1 milliseconds. That is a 30 times performance improvement. This is how you get that buttery smooth scrolling everyone wants.
And Alcinoo is way more than just fast controls. It's a whole toolbox of solutions. It has a network component that can reliably download things in the background even if your app gets shut down. It has a special list box for handling thousands of items without using a ton of memory. It even has tools that make it way easier to use third-party Android libraries and parse huge JSON files 3 to 5 times faster. Every one of these things solves a real-world problem that Delphi developers face every day. So we have better graphics, better threading, and specialized components. But how do you apply all of this to your specific app? Where are your bottlenecks? This brings us to our last and I think most important section. This is the philosophy that has to guide everything you do when it comes to performance. It's about stopping the guesswork and starting to use a real, data-driven methodology.
This phrase right here says it all. Medir, no adivinar. Measure, don't guess. This is the mantra of every great performance engineer. Why? Because your gut feeling about what's slow in your code is almost always wrong. We all do it. We spend days optimizing some function that it turns out was only using 1% of the time, while the real problem was somewhere else entirely. You have to measure. Assumptions are the enemy. Data is your only friend.
So how do we measure? You need the right tools. Your toolkit starts with the Android profiler that comes with Android Studio. You can connect it to your Delphi app and see what's happening with the CPU and memory in real time. For a much deeper look, there's Perfetto and Systrace. These are the heavy-duty tools that show you exactly what every single thread is doing millisecond by millisecond. They're the best way to hunt down UI jank. And to top it off, the Alcinoo framework even comes with its own code profiler to find the exact bottlenecks inside your Delphi code.
So we've gone from lag to liquid. We've upgraded our graphics, we've tamed the main thread, and we've learned that we have to measure everything. It's pretty clear that building a high-performance app isn't about one magic trick. It's a whole discipline. And that leaves you with a final really important question to think about for your own projects. As your apps get more and more complex, are the standard built-in tools going to be enough for your most critical systems? Or is it time to start exploring more advanced tools and frameworks to make sure your apps aren't just fast today, but are built to stay fast tomorrow?